Hello everyone, I'm Paul and today we're solving problem 1578, minimum time to make rope colorful. This is medium and in my opinion this is a fun problem, so let's start. We are given a rope with balloons of different colors. Here you can see an example. We are given a string colors where colors are characters. And for example here, character A is represented by color blue. We are also given an array needed time where each element corresponds to the required time to pop the corresponding balloon. For example, if we want to pop balloon at index 0, we go to needed time at index 0. And the required time in this case is 1. And we want to make this colorful, meaning we want to avoid consecutive balloons of the same color, meaning we want alternating colors. We want to transform something like this into something like this. And for example, here we have two balloons of the same color that are adjacent. So we need to pop one of these. Now the question is which one? And our job is to return the minimum time to make the rope colorful. So in this case, we would pop this one, because the required time to pop this is 1 and the required time to pop this is 2. And the minimum between 1 and 2 is 1, so we pop this. And we add 1 to the result. And here we also have two adjacent balloons of the same color. The required time to pop this one is 4 and the required time to pop this one is 1. And the minimum between 4 and 1 is 1, so we pop this and add 1 to the result. So in this case, we return 2. Now maybe you are thinking about iterating this from left to right, and whenever you find two adjacent balloons of the same color, you can keep the minimum time among these two and add this to the result and continue. And this is fine if you have exactly two balloons of the same color, but what if we have three balloons of the same color? Should we pop this one or this one or this one? And here is where this becomes tricky. For each balloon we have basically two choices. We can pop or not pop the balloon. Now let's say we pop this, and now we have this scenario in which we don't have this balloon and we still have these two. If we don't pop this, now we have a different scenario. So you can see how from one decision we have two possible scenarios, and here we can take another decision for another two possible scenarios, and so on. So you can solve this with dynamic programming, but here I want to show you a solution that's way more simple. Let's say we have 6 adjacent balloons of the same color. And remember, we are trying to get the minimum time to get alternating colors. So if we have 6 adjacent balloons of the same color, we should pop all of them except for one. Now, which one should we keep? And the answer is this one. Why? Well, because this is the maximum value. We need to return the minimum time to get alternating colors, so we should pop everything except for this balloon. And we need to add to the result the sum of all of these balloons that we are popping. So the overall approach here is we take the sum of all of this, meaning 5 plus 6, 11, and we subtract the maximum value, meaning the balloon that we are keeping. So we subtract 3 and we return 8. Time complexity for this approach is big O of n and space complexity big O of 1. So now let's go with the code. First, n is the length of colors. The result is 0. We start from index 0, and while I is smaller than n, every time j is equal to I. And we are using this j pointer to iterate balloons that are adjacent and have the same color until we find a balloon that has a different color. every time we are storing the needed time to pop each balloon in this variable total. This is 0 initially, and we are keeping track of the maximum value here. This is 0. Now while j is smaller than n and colors I is equal to colors j, we update j. Now before this, we need to add to total needed time at j, and the maximum is the maximum between mx and needed time at j. Now we can say result plus equal total minus mx, and this is the same, exactly the same we did a few seconds ago, okay? And every time we update the I pointer to j. Finally, we return result. So this is the entire code. I think this is right. Let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.